So the first thing I always tell students, you need to know conversions in Calc. Conversions are not formulas. Conversions are 60 seconds in 1 minute. 2.2 pounds is equal to 1 kilogram. There's no way around it. You have to memorize these. Which leads me to what I want to talk about in Calc tonight is formulas versus dimensional analysis. I have talked about formulas in my live sessions, but I have not really done too many formulas. And what I want to convince you all here for Med Dosage tonight, if you don't like dimensional analysis, I want you to like it a little bit more, because if you learn dimensional analysis, you don't have to memorize any formulas at all, with the exception of one formula. There is one formula you may have to memorize for Calc, if you even use it in your Calc course, will be body surface area. That is a formula you have to memorize. But like formulas for milliliters per hour or weight-based formulas or desired over half, I mean, some of those are okay, but they only work in certain situations. And I'm going to really show you that tonight. I think I am. That's the whole goal of tonight's Calc session. So with that said, 2 problems up here for Calc. I want y'all to work those 2 out. Now, what I want to go ahead and talk about first of all is the formula. Even though I'm not the biggest fan of formulas, there is a very common formula, and y'all have probably heard of this: desired over half times quantity. And the formula is fine in certain cases, but sometimes it is not. Now, desired over half times quantity is going to work just fine in actually both of these examples. But the one I'm going to give you right here in a second, this formula right here, it will not do it. Now, desired, sometimes people say, what is needed? What is the prescription for? That is the desired amount, and I'm just going to come in here and highlight it. This is what is needed. This formula is going to work fine here, but it's not going to work in a moment. After these 2 examples, this formula here does not work. That's what I want to stress tonight. So 500 milligrams, that is what's desired. That is what is needed, the prescription. Whereas the word have, sometimes students refer to this as what is available, what is on hand, what does the pharmacy have? Well, what's available is 200 milligrams. So 200 milligrams is what they have on hand, but it's also too, what does this thing quantity represent? In this particular example, the quantity is a tablet. It's per 1 tablet. Now, sometimes the word volume gets tied into here, and we'll see that down here. Volume is liquid. But this, what's available, this 200 milligrams, is kind of tied to the quantity. It's 200 milligrams per 1 tablet. Now, here comes something that's going to set you back, folks. If these 2 things do not match, milligrams and milligrams, or it might be micrograms and micrograms, whatever, if they don't match, you have to do a conversion to make them match. And that's one spot where people get mixed up when it comes time to do a formula. They like, okay, I got to convert, but I don't know whether I should multiply or divide. Well, in this example here, they already match up. And all we're doing here is taking 500 divided by 200, and you're essentially multiplying that by 1 tablet. Now, something about this formula, though, as if these units right here match up, milligrams over milligrams, this kind of looks somewhat like dimensional analysis, but we are essentially getting rid of those words. In dimensional analysis, that's what it's all about. But here, 500 divided by 200 times 1, that gives us 2.5, and it will be 2.5 tabs. So again, using this formula here, there's nothing wrong with the formula, but it only works in certain situations. So down here, we have a very similar example. Let me just put a little line here to divide that. These are quick. The formula does work great. I'm not hating on it too much. A client's prescribed 500 milligrams. Okay, that's what's desired. So 500 milligrams. We're going to put this over what is available. What do they have on hand? What they have on hand is 150 milligrams. These units match up. This is perfect. And then the quantity is going to be per 1 milliliter. So very similar. The only difference between these, of course, yeah, we got a number that's different. But up here, we're talking about tablets, and down here, we're talking about milliliters. So that quantity, that word quantity, can represent a number of tablets, a number of capsules, the number of milliliters. Now, we are going to get a different answer here. If we take 500 divided by 150, we get 3.3 repeated. Now, since we want to round to the nearest tenth, that's going to be 3.3 because the tenths place, y'all, don't mess up with your place value. That 3 tells that 3 to stay the same. So our answer here is 3.3. Let me fix that. That was ugly. 3.3 milliliters. Now, let me show you, before I move on, and give you all an example where desired over have does not work. So let me show you dimensional analysis. The formula's great here. I ain't gonna lie. The formula's fine. But if we wanted to do dimensional analysis, so what about DA? And that means dimensional analysis. First thing, goal. What is the goal of our problem? We are trying to find how many tablets. That is our goal. The thing I like about dimensional analysis, you can actually skip the whole daggone problem and look and see what the question's asking you to find. How many tablets? That is our goal. And I can act as if I haven't read anything else. All I got to do to start off my dimensional analysis is look at the question. Our goal is tablets, so watch what I'm going to do. I'm going to make that word tablet the first word in my first fraction. The top word in my first fraction. Now, there's no formula. I'm not giving you a formula. This is what people ask me a lot. They're like, how do I get started? I'm trying to show you. I'm trying to tell you right now how to get started. How many tablets? I'm starting off with tablets. Now, if we go back and we read into our problem, we know that we have 200 milligrams scored tablets. Do not put 200 up here. If you wrote 200 there, you are saying 200 tablets. That is not correct. What this is saying right here, y'all, what I've underlined in purple, what this is saying is that each tablet, one tablet is 200 milligrams. So that's how we're separating these two words. We need tablet. We're trying to figure out how many tablets. So I'm starting off with tablets at the top. One tablet is 200 milligrams. We need to get rid of one of these words. And this is how dimensional analysis works. And we're going to see two long ones tonight. But to get rid of milligrams, that's the one we want to get rid of. We don't want to get rid of tablets, y'all. That's what the question's asking. How many tablets? Keep that word. So therefore, we want to get rid of milligrams, and I'm going to throw this at the top. And the reason I'm doing this is because in dimensional analysis, you want to get rid of words that you don't want. Our goal does not care about milligrams. It doesn't say how many milligrams. It says how many tablets. So we have to get rid of milligrams. And now, yes, some of y'all are like, okay, we're going to bring in what's desired. But honestly, you don't have to worry about desired and available. The one tablet was connected to 200 milligrams. And to get rid of milligrams, we're going to put the milligrams at the top. 500 milligrams. What do we put this over? One understood dose. That's the one dose or the one order or the one prescription. But in all honesty, y'all, I want you to see how we're really just taking 500 divided by 200. But this is the fundamental building blocks of dimensional analysis. This one, I wouldn't refer to it as patient. The one, when I will tonight actually, I will use the number 1 to refer to the patient, and that is when I bring in a patient or a client's weight. that one would truly mean the one client, the one patient. In this case here, this 500 milligrams does not mean the one patient. It's the one dose or the one prescription. Honestly, it's more of just a placeholder, but the one technically does have a meaning. But again, here, we're just taking 500 divided by 200. Do not divide 200 by 500. When you divide, it does matter the order of division. It doesn't matter what order that you multiply two numbers. It does not matter the order that you add two numbers, but it does matter how you divide two numbers. So 2.5, and by the way, this word right here, how can I be confident that this word is the only word I have left? How can I be confident that this 2.5 truly represents tablets? That's the dimensional analysis. There is no other daggone word left in this problem. We got rid of the milligrams. And our goal was tablets. That's the only word we have left. We've met our goal. We can move on. And speaking of moving on, I popped this crazy problem up here. And it's going back to something talking about volume. If we look back here, this question earlier is how many milliliters will the nurse administer to the client? That was a quick one. A couple of reasons why. One reason, these units matched up. Another reason, there was no client weight involved. There were no conversions needed. And that's where things can get messy when you start throwing in clients' weights, conversions, and all of that. Well, guess what? This problem has all of it. And this is where dimensional analysis is really going to shine. Good luck using a formula. If you were to Google this and say, give me a formula for milliliters per day, you don't do it. I told you to do it, but don't do it. If you try to memorize formulas for every specific type of problem on top of trying to memorize conversions, it's not going to work out well for you. Whereas if you follow dimensional analysis, what's the first thing? Dimensional analysis. Goal. How many milliliters per day? That's what we're trying to figure out here, y'all. So our goal, we have two words. Absolutely, these two words are important. Somebody said, oh man, I've overlooked the day. I get it. But our goal is how many milliliters per day. I did this on purpose. Some of y'all may have got stuck with the 4 divided doses. And I'm going to go ahead and tell you, I could care less about those doses for this problem. And dimensional analysis will explain why. So our goal is milliliters per day. And y'all, I tell you what, this is how I'm trying to really teach you dimensional analysis. Ignore the whole problem and look at the question. How many milliliters per day? Milliliters is the first word I want to focus my attention on. I don't care about the word day. The only thing I care about right now in this instant is the word milliliters. Y'all, don't worry about day yet. We'll worry about that in a minute. That top word is so important. That's the most important thing to us right now. So we need milliliters at the top of our first fraction. Now I'm going to look back at my problem and I'm going to hunt. I don't care about that yet. I don't care about that yet. I don't care about 4 divided doses yet, or maybe at all. Ooh, I do care about that. This is helping you. You don't care about any other word in this problem except for that word right there. I cannot stress that enough. That's the word you want to hunt down. So what do we know about milliliters, y'all? In this problem, we know 3 milliliters. Yes, I'm putting the 3. I'm not putting the 2 first. There is nothing wrong with us. Let me come here and just get rid of all this other stuff too. Clean it up a little bit. But there is nothing wrong with us flipping a fraction. Absolutely nothing wrong with us doing that. And you might say to yourself, well, why are you putting the 3 up top? Why are you flipping it? It's all about the goal. We want milliliters at the top. So we know in 3 milliliters of this liquid, there are 2 milligrams of medication. So we are using this because it had that first word we needed, the word milliliters. Again, I know I kind of unerased it, but I didn't care about the 230 pounds yet. I didn't care about this. I didn't care about this or this. All I cared about was the word milliliters to get started. Now let's move on. We need milliliters per day. We have to be patient because right now we have milligrams at the bottom and we need to get rid of it. So if milligrams is at the bottom, I'm going to put milligrams at the top. Now I'm going to look back at my problem. Now, y'all, we don't want to repeat information. We will not use that anymore whatsoever, what I'm crossing out right there. That's done. So we need to look back at our problem and say, okay, I don't see milligrams there. I don't see milligrams there. 4 divided doses. I don't see that either. Well, the only thing that's remotely close to milligrams is micrograms. I'm not going to touch this calculator. I know I just cleared it out. I'm not going to touch it yet. The only thing I'm going to do is I'm going to write down a conversion. We don't have milligrams anywhere else in this problem, but we do have micrograms. And the conversion, this is not correct. That is not correct. 1,000 milligrams is 1 microgram? Nope, that's not correct. 1 milligram is equal to 1,000 micrograms. That is a common thing where students mess up. Because I ask students, okay, what's the conversion? And students will tell me 1,000. Literally, I bet some of y'all are guilty of that. I will ask students, what is the conversion from milligrams and micrograms? And they will say 1,000. And then I'm like, 1,000 what? 1,000 has to go with the micrograms. 1,000 micrograms is 1 milligram. And then they're saying, well, how do I know to put the 1 in the milligram up here? Well, y'all, that is how we get rid of words. The milligram had to go at the top so that we could cancel out with this milligram at the bottom. And 1 milligram is 1,000 micrograms. Now, the whole point of us doing this, we converted to micrograms. I'm going to bring in the double slash. That's what I call it in the workbook. 375 micrograms. Yes, I can bring that in because I'm about to cross out those words. 375 micrograms per kilogram per day. Now look at how I did it. If you go to my Med Dosage website, if you have seen my videos, you have heard me mention the double slash, and this is how I handle the double slash. These 2 words, kilogram and day, these are the 2 words that will stay together. Notice I put kilogram and day at the bottom, and microgram, I kept it at the top. So what have we accomplished? Microgram was down here. We put microgram at the top. They cancel out. Now let's put the brakes on. Let's think about this, y'all. Right now, we have milliliters at the top and we have kilogram and day at the bottom. We haven't met our goal yet, but we are almost at our goal. In order for us to meet our goal, the only word we want at the top is milliliters. That's good. Where we're messed up right now, or we're not messed up, but where we're not done, the word day, yes, it is at the bottom, but we have to get rid of kilograms. And to get rid of any word, just like I've done the whole time, if I got kilograms at the bottom, I'm going to put kilograms at the top. And if I look back at my problem, I do not see kilograms other than that one. I've already used that one. Other than that word kilogram, I don't see kilogram getting mentioned anywhere else, but I do see a 230-pound client. We need to do another conversion. And some of y'all may be thinking, oh, I'm just going to divide this by 2.2. Technically, that's right, but I am not touching the calculator until I've met this goal. Not touching the calculator, not going to round anything. I'm going to meet my goal of milliliters per day. Then I'm going to type it all into the calculator. So what is that conversion? A lot of times students will say, oh, 2.2. 2.2 what? And then they get mixed up. It's 2.2 pounds is equal to 1 kilogram. But since I have kilogram at the top, we have to put the 1 kilogram because 1 kilogram is equal to 2.2 pounds. Why did I put it in this order? Kilograms cancel out. Now, daggone it. Now we got milliliters at the top. We got day at the bottom, but we got pounds at the bottom. We have to get rid of pounds, bring in that 230 pound client. 230 pounds. I'm going to put that at the top. And I'm going to put that over 1. This is not one dose or one prescription. This 1 represents that one client that weighs 230 pounds. Pounds cancel out. Now look at what we have, y'all. If this is your first time seeing dimensional analysis, you're like, man, this is nuts. This is crazy. But I'm telling you, dimensional analysis works for every single dose calc problem. You don't have to memorize any formulas. Those formulas that I've mentioned that only work in certain situations, you don't have to memorize those. Dimensional analysis will do it all, I promise you. But hallelujah, finally, we have met our goal. I'm putting an equals down. Why have we met our goal? We started off with milliliters. Every time, start off with that top word. And we needed day at the bottom. And we got day at the bottom right there, but we still had to work on getting rid of the kilograms, getting rid of the pounds. And now watch how I'm going to type this in. I'm going to look at my top numbers. I always skip my ones. I see a 3, a 375, and a 230. So 3 times 375 times 230. I am multiplying them. Y'all, I'm not even going to press equals. What you can do is you can immediately divide by 2. We have a 2 at the bottom. I'm going to divide again by 1,000. And then I'm going to divide again by 2.2. This will always work. You multiply your top numbers and you divide by your bottom numbers. And I want y'all to notice that I typed it all in at once. Sure, you may have a teacher that taught you multiply your top numbers, multiply your bottom numbers, then divide them. You can, but you're pressing equals more often. You are writing down more stuff. I promise you can always do it this way. Now, I do have a question over in Zoom as well as Google Meet. So now that I'm done with this problem, what did we not use? We did not use the 4 doses. The reason why, it's all about the goal. It's all about the goal. The goal was milliliters per day. We started off with milliliters. You get rid of stuff. And like right here, we got rid of milligrams. We got rid of micrograms. And what happened right here, y'all? What happened right here? The word day popped up because that was what was with the 375 micrograms per kilogram per day. The word day popped up right here. Those are the 2 words. Milliliters and day are the 2 words that we want. So then the next thing we had to focus on, yes, we got our 2 words, but we had to get rid of kilograms. So how are we getting rid of kilograms? You're always going to tie in a client's weight here. You're always going to bring in a client's weight to get rid of kilograms. Now, it does depend whether the client's weight is already in kilograms or if you have to convert. But the reason why we didn't use the doses, the 4 divided doses, this question did not say how many milliliters will the client receive each dose. It says each day. We already had day. There is no need to divide it up into doses because the question said per day. And what I call that, and y'all, I have an entire live session on that. By the way, too, this answer is going to be 59 milliliters per day because I did say round to the nearest whole number. So that 8 right here tells that 8 to go up to a 9, 59 milliliters. That is a tricky one. I have an entire live session on something called distractors. This 4 divided doses, it was a distractor for this question. However, had this question said how many milliliters will the client receive each dose, then you would need to use the 4. And in all honesty there, what you would do is you would just take that daily amount and you would divide it up into 4 doses. But that would then give you milliliters per dose, not milliliters per day. That is a different question. Now, next problem for med dosage, we're going to move on to another type of question that comes with formulas is milliliters per hour and drops per minute. So here we go. A very common, popular formula, but it is as bare bones basic as it gets, y'all. If you are trying to find something called the infusion rate, this is a formula. If you were to Google infusion rate or how to find milliliters per hour, this is the formula that you will see. However, this formula is extremely limited, and we're going to see that in our next, not these two, but we will see it in an upcoming problem. So in this first one, the formula is fine. I mean, it works great. Total volume in milliliters. Total volume, the client needs 800 milliliters in all. The time over the next 5 hours. And y'all, literally, I want you to see technically dimensional analysis is still happening. What is our goal? Our goal is milliliters per hour, right? That's what the question's asking. So milliliters is going at the top. And it just so happens in this problem that we know those 800 milliliters is directly connected to 5 hours. That's why this formula works, because we know how many milliliters, we know the total time in hours. 800 divided by 5, that is 160 milliliters per hour. And just like that, yeah, that formula works great. Now, with the next one, let me copy over GTTs per minute. And see, here's the thing, y'all. I hope y'all are starting to realize I'm copying over these formulas, and I'm like, we've had what? How many formulas tonight? 3 different formulas. The desired overhave, milliliters per hour, and now drip rate, drops per minute. Now we have to be careful with this one. Total volume, 200 milliliters, times the drop factor, 20 drops per milliliter. So we're going to multiply that. And I tell you what, I mean, for now, watch what I'm going to do. I'm going to take away the words. This is where formulas can be confusing too. But the 200 is the total volume. That's how much the client's going to receive. Times the drop factor. Drop factor is 20 drops per milliliter. So we're going to multiply by 20 up top. And then it says that we need to divide. I'm just coming here. Let me highlight everything. And this is where you got to be careful. Do not divide by 4. In order for this formula to work, you got to have the time in minutes. And technically the reason why you got to have that, y'all, is because we want drops per minute. Well, we have to be careful here. The 4 hours, if you want to use the formula, you do need to multiply. You need to know, hey, if there's 4 hours, we take 4 hours, we multiply it by 60. Because there's 60 minutes in every hour. 1 hour would be 60 minutes. 2 hours would be 120 minutes. 3 hours would be 180 minutes. And 4 hours, 4 times 60, that is a total of 240 minutes. You have to use, so that's one spot you might have slipped up on. You might have overlooked the time. The total time is 4 hours, but it needs to be in minutes. So we have to divide by 240. So take the 200 times 20 divided by 240, and our answer here is going to be approximately, or I'll tell you, equals, and let's say 17 drops per minute. By the way, for drops per minute, most of the time you need to round to the nearest whole number. Drops per minute. So the 6 tells that 6 to go up. And if you haven't been told that, if you're just starting Dose Calc upcoming this fall semester, you will hear that soon enough. Drops per minute, nearest whole number. So y'all, these formulas work okay, right? I mean, especially this one. I mean, this one, we had milliliters, we had hours. Down here, we had to change one thing. But if we go back and look at what I've done tonight, I've given y'all desired overhave times quantity. And then we did dimensional analysis, which I love. I know it looks crazy. But then we did infusion rate and we did drip rate. That's 3 different formulas for 3 different problems, and those formulas only work for certain situations, in certain situations. Whereas these formulas that I've given you here, yes, and I'm going to go ahead and underline something. In this last problem for Dose Calc tonight, we are trying to find how many milliliters per hour. I'm going to go on and tell you that formula shot out the window. Does not work, yet we still need to find the same thing. We're trying to find milliliters per hour. We cannot use that formula here, even though our goal is the same thing. Our goal is still milliliters per hour. And y'all, again, I don't care what the problem says. I literally see many problems like this. Dose count problems, I see several every day, pretty much. I mean, yeah, there are some days when I don't see a dose count problem, but pretty much every single day I see a dose count problem. The first thing I do, I find the question. I establish my goal. I am showing you all exactly how I do it. I read the question, I establish my goal, and now I start to do my dimensional analysis. Let's start off with milliliters at the top. That's the word I care about. We have a whole bunch of numbers. We got 120 pounds. We got 0.3 micrograms per kilogram per minute. We got 10 milligrams. Oh, that's the one I care about, y'all. This is the one I care about. There's a whole bunch of numbers up here. We don't know what to use. Well, I'm trying to show you what to use. We need milliliters. This is the only thing that mentions milliliters. So I'm going to put that 100 at the top because our goal, we need milliliters at the top, y'all. So what do we know about these 100 milliliters? In that 100 milliliters of fluid, liquid, there are 10 milligrams of medication. So I'm going to put the 10 milligrams at the bottom. By the way, this D5W dextrose 5% water solution, odds are you will never use that in any dose count problem. But anyway, in that 100 milliliters, there's 10 milligrams of medication. We need to get rid of milligrams. I mean, yes, I know I haven't wrote the word hour yet. We have to wait. Y'all, you just can't go and stick hour down here. Nowhere in this problem does it say 100 milliliters per hour. You cannot just stick a random word in here. You have to make sure you're getting that information from your problem. So 100 milliliters, 10 milligrams. We need to get rid of milligrams. Do y'all see milligrams getting mentioned anywhere else up here? Again, we don't want to repeat information, so we don't want to use that right there anymore. And I don't see milligrams getting mentioned anywhere else, but we have to get rid of it. But what I do see is I see the micrograms. So what we're going to do is we're going to do a conversion. This is why you need to memorize conversions. Now, we're trying to convert from milligrams to micrograms. Milligrams is at the top, and the conversion is this. In 1 milligram, there are 1,000 micrograms. We've converted. I have not touched my calculator. I'm not doing any calculations. I'm not trying to multiply or divide in my head. I'm going to wait until I meet this goal, and then I'm going to come over here to the calculator and type it in. So we've converted. Now we can bring in these 0.3 micrograms. And by the way, watch what I'm doing. I'm putting micrograms at the top so that we can cancel out with micrograms at the bottom. And the problem states 0.3 micrograms. Here's our double slash. We got 2 words here, kilograms and minutes. What was it earlier tonight? It's not always going to be the same 2 words. But whatever those 2 words are in our double slash, I'm going to keep them together. Kilograms and minutes. What have we accomplished? Micrograms cancel out. Now going back to this goal, we need milliliters per hour. We're still not there yet. Yes, we have milliliters at the top. Fantastic. But we have kilograms and minutes at the bottom. We have to get rid of both of these words. It does not matter which one you get rid of first. That has a tendency to throw people off. They're like, well, which one do I get rid of? Both of them. Which one do I get rid of first? It doesn't matter. I'm going to get rid of kilograms. So I got kilograms at the bottom. I'm going to put kilograms at the top. Unfortunately, we don't see kilograms getting mentioned anywhere else, but we do see pounds. So we're going to do another conversion. Y'all, I'm not doing any math right now. You might say, yes, you are. Technically, I'm not doing any calculating. All I'm really doing is I am writing down words and numbers. And there is a method to me writing down these words and these numbers. That's all I'm doing. I'm not doing math right now, y'all. I want y'all to understand that. We're writing down numbers and words. So kilograms cancel out. We converted to pounds. And why did we convert to pounds? Because the client's weight was given to us in pounds. 120 pounds represents that one client. Pounds cancel out. Now, if we stop here, man, you were so close. But we don't want to stop here. If you stopped right here, you would have milliliters per minute. But we want milliliters per hour. Our goal is milliliters per hour. We still have to get rid of a word. We have to get rid of the word minute. And you may say, oh man, I thought you said that we had to have the words beside each other. I didn't say that. I've never said that. I have the word minute at the bottom. I never said you had to put them beside each other. What I said you had to do is that, hey, we have a word at the bottom. To get rid of it, we got to put the word at the top. I never said they had to be beside each other. As long as you got a word at the bottom and a word at the top in your dimensional analysis, those words will cancel out. I'm going to use another conversion. There are 60, watch this, there are 60 minutes in what? 1 hour. Why did I do this? Now, true, I mean, do we agree? There's 60 minutes in 1 hour. The reason I did this, get rid of minutes, and hallelujah, look at what we have done. We started off with milliliters. We did a whole bunch of craziness, and now we have met our goal. Milliliters and hours are the only words we have left in our dimensional analysis. I know it's crazy if you're just getting started, but I have literally taught this technique to thousands and thousands and thousands of people, whether it be through my videos, through my website, Facebook group, or even one-on-one tutoring. I tutor students just about every day of the week, but very often I'm teaching dimensional analysis, either that or T's. 90% of the time it's either T's or med dosage. And so many people, they don't like this method at first because it looks insane, but at the end of the day, they're like, oh my gosh, I wish I had been taught this way sooner. Because you don't have to memorize formulas. It's the same process. Establish your goal. Start off with that top word, whatever it may be. Work on getting rid of words that you don't want until you meet your goal. That is the process. And when you meet the goal, that's when we're ready to calculate. So therefore, when we multiply our top numbers, we have 100, multiply our top numbers, times 0.3, times another top number of 120, times another number of 60. We need to immediately divide by 10. We have another number to divide by at the bottom, 1,000. We have another number to divide by at the bottom, 2.2. I'm going to type that in, and I'm finally going to press equals. This is the answer that we're after. And again, I want you to see that I typed everything in at once. I didn't tell you what to round to here. Let's just round to the nearest whole number, I guess. So 9.8 milliliters per hour. We will round that off to 10 milliliters per hour. Just bear in mind, you'll be told what to round to, or your school, your program will give you rounding rules, hopefully. So med dosage, dimensional analysis, that's how I like to do it. But hopefully tonight I did kind of hit home on, yeah, I mean, I still do use formulas from time to time, or honestly, what do I do the most? Most of the time, I grab a calculator as soon as I read a problem because I've been doing this longer than some of y'all have been living. I've been teaching math for almost 20 years, so I can read a problem and I can know when I need to multiply by something versus when to divide. But when my brain gets mixed up, most of the time I am writing out a dimensional analysis problem and I'm crossing out those words. Well, ladies and gentlemen, if we have any guys in here, whatever, I hope y'all found it helpful. Y'all take care. Have a good rest of your evening. Good night.